I'm gonna get started right now because it's exactly 10:30. Just a mild reminder that your final exam is on May 10th, which is exactly 4 weeks from today. The start time of your final exam is not the same as your class time. It starts at 10:15, so you need to come here 15 minutes earlier, just to be on time for the final exam. I suggest that you come a little bit earlier so you have some time to settle down, lay your stuff out before the exam starts. We probably won't be able to come into the classroom until 10 o'clock anyway, so sometime between 10 and 10:15 will be good. The final exam will be comprehensive. It's going to be open book, open notes, just like with the other two exams. So we'll also have a practice final exam before the actual final exam, which is also 1 week right before the final exam. So that way you know kind of what type of question will be asked. Last time someone asked me, how many questions will we have in the final exam? Because it's going to be proportional to the amount of time, we're going to have about 6 questions in the final exam. Are there any questions about the final exam? No questions?
You said that we can open book and open note.
Yeah.
And can we this case be like handwriting or is print?
You can be printed or handwritten, but you cannot use a laptop computer during the exam, so it has to be paper-based.
Okay.
Yep. All right. So just Tuesday, we were talking about types, and we talked about the three different types that we normally use for programming. And I think we stopped with this particular topic. We talked about strings and how strings are a little bit different. Do you guys have any questions? Can I answer your question? No? Okay. So what a string is it's only useful for representing text information. Now what is text information? That would be your first name, your last name. That's text information. But we also have different types of text information. Last time we were using some numbers, and I was telling you guys how the comparison of a string is different from the comparison of actual numbers. So instead of using the whiteboard, which I did last time, I'm going to use the mouse pad this time so that this will also be recorded as a part of the class recording. And I think this part may have been a little bit confusing because it's not natural, because we don't really think this way, but the computer does. So we'll go ahead and use a slightly larger font. Okay, so normally when we look at 15, we consider 15 to be greater than 6. Okay, that's pretty obvious. As a number, 15 is greater than 6. The next question is, what if I look at 1, 5 as a string and I look at 6 as a string? How do I compare those two? And before we answer that question, let me just go ahead and ask you, lexically speaking, in other words, when you look up a dictionary, which word will come first? We'll pick something that is obvious. We'll pick text as one word, and we'll pick cup as the other word. When you look up a dictionary, which ones will appear first? Cup, C-U-P comes first. So in terms of comparison, a lot of programming languages will claim that this is how they are related. The greater than in this case means text comes later in the dictionary. Is that making any sense so far? Okay. Let me ask you another question. What about text versus textile? Which one comes first in the dictionary? Text comes first, so in the computer, when you perform a comparison, this expression will be true because text goes before textile. Are we doing okay so far? Okay. So here comes the next question. What if I'm comparing 1, 5 versus 6, and both are considered strings, not considered numbers? Which one will come first? 1, 5 will come before 6 because the digit 1 is considered before the digit 6, and we don't even care about the 5 because after we compare the first letter of this one and also this one, we have a conclusion already. We don't even bother to look at the 5 that is next to it. So that's string comparison. It is not using the numerical value. It is simply looking at the two double quoted things, character by character, or byte by byte, or letter by letter, or digit by digit, until an order can be determined. Are we doing okay so far? Distinguishing the concept of number comparison, which is up here, from string comparison, which is down here. Okay. Now, when you use strings in an actual programming language, you can use it to represent just about anything that is text-based. So that would include names, addresses, city names, states, and so on and so forth. And that's where we stopped last time. This was the last topic that we were talking about. We were also, I take it back. We actually talked a little bit more. We also talked about records. And the analogy of a record is it is a form. And I use a comparison, I use an analogy and say that what if we do not have forms, a form that has 30 or 40 different little fields to fill in. Instead, each field is a little slip of paper, and you end up with a pile of these little slips of paper instead of a big form. That was the comparison that I was making last time. Do you guys still remember that? And the conclusion was a form is better because if you want to make a photocopy of a filled form, you just need to put that piece of paper on a copier, run it through once, and then you have a copy of the entire form. On the other hand, if you have 40 little slips of paper, then you have to make photocopies of each little slip of paper in order to make a copy of the entire record. Is that okay so far? That's basically what we talked about last time. And so we can now start with section 5 this time. And we'll go with, well, this is an example using complex numbers. Let's not look at this complex number example. Instead, we'll go ahead and take a look at another example. Something that's a little bit more intuitive and everybody has to deal with on a daily basis. When we define a record, we just start with the word record in this class, and we end with the word end record. Just like with define sub, we end with end define sub. If ends with end if, while ends with end while, and so on. How do we represent a date in human ways? MMDD YYYY. Yeah, but okay. What pieces of information should we store?
Day, month, year.
Day of month, and then we have month, and then the year. That seems to make sense. So what we'll do is we'll also go ahead and we'll try to represent what a date is. So a date has a year field, and this is the first time we start to use this notation. When I say year colon integer, that means this particular field inside a date can only be an integer. It cannot be a fractional number. In fact, we'll also say that this is not just record, it is defining the record name called date. I'll explain how that name date will come in handy later. What else do we need in order to represent a date? Month, okay, which is also an integer. And we also need a day of month. I'll just call it day in this case, which is also an integer. And record. So right here we have defined a record type called date, and it has 3 individual items. Each item is an integer. The first item has a name of year, Y-E-A-R. The second one has a name of month, and the last one has a name of day. How is this different from arrays? It seems like we're still making bigger objects from smaller objects, which arrays are, but how is this different from an array of 3 integers?
You can have different things besides integers.
I can use different things other than integers, but I can also choose to use only integers if I want to. But there's one other major difference here. How do you address, or how do you pinpoint individual items within an array? You use an index. In other words, you use a square bracket notation, and you say, I want to access element 0, 1, or 2, when you have only 3 items in the array. In this case, how do you think we're going to access the individual items within a record?
By the item.
By its name, okay? By its name. In other words, in this case, year is a name of a particular field or component. Month and day are the other two. Yep, go ahead.
Wait, but if you say that the month is integer number, what happens if we put like 15 to month?
It is fine, because it's just an integer. In other words, we cannot enforce the month has a valid value. We can only say that it can be in an integer at this point. Okay. There are programming languages that can allow you to specify a range of numbers. In other words, in those particular programming languages, you can say a month has to be an integer from 1 to 12.
Yeah.
But that is not going to be very helpful when it comes to day of month. It should be able to go from 1 to 31, but depending on the year, February can have 28 or 29 days. So there's really not a whole lot you can do, at this level to make sure that the values inside each particular item is valid. I mean, the validation takes additional code and additional logic. That's a good question. Okay, so what we'll do is we'll just go ahead and make a very simple program, and we'll say define stub, because all I want to do is to show you how things are represented first, and also what makes a variable different from a record type. Now that's also a very important idea. So we have a local variable, and we'll just call this variable date1, and it has a type of date. In other words, I'm using the colon notation to separate the name of the local variable, in this case, from what type it has. Okay, it has a type of date in this case. And then we can say, date1 dot year gets the value of 2012. Date1 dot month gets a value of 4 because it's April, and date1 dot day gets a value of 12 because today is the 12th of the month. And define sub, invoke stub, and that would be our little sample program to trace, and its only purpose is to illustrate the different concepts involving records. So we'll go ahead and give these lines line numbers, and save the file first before I forget. And then we'll trace it. We don't really need comments in this case because I'm not printing anything. We can start with line number. There's nothing to say about the precondition because we don't have any global variables. Hold on a second here. But isn't date a global variable? It's defined outside of the context of any subroutine. So what exactly is it? If it's not a global variable, what is it? Date itself is a type. It's just like integer is a type, Boolean is a type, string is a type. Date is my own specific type. It's a user-defined type. Okay? So later on, I'll give you another analogy, so it's very easy to remember what exactly is a type versus what is a variable. Okay? But at this point, we'll just continue to execute the program starting on line 12. Line 12 is a simple invocation of a subroutine that does not return a value. So return line number is more than sufficient. And we'll just say that when we get back, we have to get back to post. But now we have a problem because we have a local variable. The local variable date1 is not an integer, it's not a Boolean, it's not a string. It is of the type date. So the question now is, how do you think we should represent date1 as a local variable? How many columns should it take up?
Just one.
It takes up 3 columns because within any type of date type variable, there are 3 individual components. So each component takes up 1 column in this case. So that means when we specify date1, we have to say column C is a part of date1. It is only responsible for the component called year. And by the way, year is also called a field. It's also called a member of date1 in this case. Those are all synonyms to being a field and component or an attribute or a member. It has 2 other fields. It has month. It also has day. So date 1 is actually using 3 columns in order to represent it because it has 3 individual components. But since it is a local variable, every single component starts with an unknown value. Are we doing okay so far with this part of the trace? It behaves just like any other local variable. In other words, it only starts to exist when the subroutine is invoked. It starts with unknown values. It's just that it takes up 3 columns in this case, and each column starts with a question mark because we have no idea what those values are when we first start this program. Then we continue execution inside the subroutine starting on line 8. Line 8 is actually pretty self-explanatory. Line 8 says date1.year gets a value of 2012. The dot symbol is a fairly universal symbol. It is in C++, it's in C, it's in Java, it's in Visual Basic, it's in Perl, it's in PHP, it is in Python. So almost every modern programming language uses the dot for one particular purpose. It's basically the same as apostrophe S in English. How do you use apostrophe S in English?
Show possession.
It shows possession, exactly. So in this case, if you look at line 8, you can read this line as date 1's year gets a value of 2012. So that means column C is going to be changed to 2012, and line 9, means we want to change the member called month to 4. Line 10 changes day to 12, and then we get to line 11, which is kind of silly because there's really not much we are doing with these values, but this is the whole point of the sample program, is to show you how things are represented and also the dot notation. So on line 11, it's the end of the subroutine. We look up the return line number column. It tells me that we have to continue execution at post, and then we also have to remember to deallocate all the columns to be allocated earlier. In this case, there are 4 columns to deallocate. Like that. That's the end of the trace. Are we doing okay so far? The big question, or I think where confusion can happen, is what exactly is date with an uppercase D, and what is exactly date 1 with a lowercase d? Date, if you look at date with an uppercase D, which is up here, this is a cookie cutter. Okay, it's a cookie cutter. It defines a particular shape, and you can use it to cut out cookies. But by itself, it is not very useful. Can you eat a cookie cutter? Probably not, okay, unless you're a bender, right? Bender probably can do it. But we cannot. Okay, even Cookie Monster, cannot eat a cookie cutter. Okay? Does a cookie cutter take up cookie dough? No, it's not made out of cookie dough. It's made out of something else. When you look at date 1, it's a piece of cookie. Okay? And how do you think we stamped out date 1? Which cookie cutter do we use to stamp out date 1? Date. Okay? So that means date with the uppercase D, or the definition of the record itself. This defines the shape of a cookie cutter. That's all that it's doing. It's just making a cookie cutter out of something. It defines the shape, and it also gives the cookie cutter a name. In this case, it's uppercase D, date. But when you need to define, or when you need to use it to create variables or parameters and whatnot, then you are using the cookie cutter to stamp out cookies. So date 1 is a cookie, but it has the shape of a date, because we can see that it has a year, it has a month, it also has a day. Yep.
The colon, I guess I was always kind of confused by that. So in the first use case, you're assigning an integer value using the colon.
Yes.
In the other case, using a function. So what scope can that have?
With a colon?
Yeah, is there things that it can't assign?
The colon is really, okay, if you do not want to use colon, you can basically replace a colon and say, year is an integer.
Right.
because it's just indicating the type of the component.
No, but I was saying it's also using it to call the function date, right?
Correct.
Yeah, so I guess that was my...
Because every time you need to indicate the type of something, you can use the colon to separate what you're trying to define and what is the type of that thing that you're trying to define.
Okay, so you can assign the type and value.
You can, well, date one is a local variable. And from now on, we are more type conscious. So every time we define a variable, we have to think, okay, but what is it? Is it an integer? Is it a Boolean? Is it a string? Or in this case, is it a date? Because if it is an integer, there are only certain things you can do with an integer. If it is a date, there are only certain things you can do with a date.
Right, so, okay, that was, I guess, where my confusion came. So on line 7, it's actually saying this is the type. It's assigning the type to date.
It's assigning a type to date one being a local variable. Yep. So are we okay with this trace? The purpose of this trace is to illustrate how do you define a cookie cutter. Line 1 up to line 5 defines a cookie cutter. Line 7 is cutting out a cookie. Now, what do you think represents cookie dough in our traces? Remember what I said? A cookie cutter does not use up cookie dough, but every time you use a cookie cutter to stamp out a cookie, you have to use cookie dough. So what do you think is cookie dough in our traces? The columns. The columns, every single column after column B, they are basically cookie dough. When you use any variable, it's using up cookie dough. So every variable is going to use up, guess what? Cookie dough. And cookie dough is basically computer memory. So variables will use up computer memory, but the type itself does not. Are there any questions about the distinction between the type versus a variable itself? No questions? Okay. The last time I also asked, how many people have heard of the term object-oriented programming, right? And some people, raised your hand and said that you have some exposure to object-oriented programming. In object-oriented programming, the term cookie cutter is also called a class. The term object is basically the cookie. Okay, so that's basically how the terms are equivalent to each other depending on the context. In this class, we don't really use object-oriented programming, so we'll still continue to use the terms type versus variable. But when you move on to C++, then you will start to encounter the term called class. A class is basically a cookie cutter, and you will also encounter the term called an object. An object is a cookie. Okay? Any questions about this before we move on? Yep, go ahead.
Can you say what object, class, and whatever else you said for this without using the cookie illustration because it's throwing me off? Just like what is the object in this, I guess?
The object in this case is date one. Date one is an object. And the class is date. Because what we understand as record in this class or in more procedural programming will later on become classes in object-oriented programming. Yep.
What would line 2 through 4 be in the reference of cookie dough?
That's basically internal to the shape of a cookie. What are the components inside the cookie? So some cookies only have one extension, and this one has 3 components inside the cookie. You can also look at this as a form. If you look at this as a form, line 1 to line 5 defines the template of a form. It's basically an empty form. And then line 7 is an actual form that we can fill in. Yep.
So the records look like similar to the array, right?
No, it is not like an array because we do not get to each individual item by its index number. We get to each individual item by its name.
But it's still like...
It's a collection. Yes, it is still a bag or collection of
exactly.
items.
But what happens if we had like 100,000 value
Uh-huh.
in that part, and which one it work better? The array going to be work better of the record?
It depends on whether you want to be able to get to each individual item using a formula or using a loop, or do you want to get to each individual item by its name?
Yeah, but I mean, which one is? This doesn't matter. Like, which one?
They're completely different things. You know, arrays are only useful when you want to get to items using indexing, and records are useful when you do not need to get to items using indexing. They can mix and match too. Those two concepts are not opposing each other. You can have an array of records. You can have a record that also has an array as a component inside it. Are we doing okay so far with this? Kind of? Okay. Let's go ahead and make another subroutine or another sample program using these concepts. I have saved this one already, and we'll go ahead and make a new one. I'm going to close the other one and make a new one. And this new one is also going to use the date type. And we'll still use, in this case, I'll just use y as an integer because I don't want to type a whole lot. M as to represent our month, D to represent our date, and record. And what I want to do is to define a subroutine that can determine whether one particular date is before another date or not. Is that okay so far? Okay. So I will call the subroutine is before. It's going to take two parameters. The first parameter, which I will pass by value in this case, is going to be the first date. Okay, so first date is of the type date. And then we have a second parameter, which is also of the date type. That's our second date. How do we determine whether one date is before the other one? What do you evaluate first? We evaluate the year first. Very good. So we can say, well, I'm just going to, this is somewhat redundant, but we'll go ahead and say a result here. In this case, the result is a Boolean, because we are now much more type conscious than before. So instead of just saying that we have a local variable called result, we want to make sure that we also understand what the result is. What is the type of the result? In this case, the result is either true or false. Does it seem to make sense to you that the result of a subroutine with a name of is before is going to be true or false? Seems to make sense. Okay, so what we'll do is we'll go ahead and write the logic of this subroutine. So someone's already suggested if first dot y, the year of the first date, is before the year of the second date, then you can make a conclusion already. You can say result is true. Okay. And then you can also say else if the year of the first date is greater than the year of the second date, then you also know for sure that the result is false. Is that making any sense? The only time you cannot determine right away is when they are exactly the same. When the year of the first date and the year of the second date are exactly the same, then what do?
You change the value of the month.
You look at the month. Very good. So in this particular else, we will handle that particular case. So we'll say if first.m is less than second.m, then we know for sure the result is true. And it's the same thing, else if the month of the first date is greater than the month of the second date, then we also know for sure that the result is false. But what if the, okay, let me fix the indentation first, because this gets a little bit hard to read at this point, unless I fix the indentation first. So what does it mean if I get to this else here?
The same year and same month.
Yep, we're talking about the same year and the same month. So what do I need to do here? I need to compare something, right? What do I need to compare? Well, we only have one thing left. The day of month of the first date has to be compared to the day of month of the second date. If it is less than, then the result is true. And for everything else, the result is going to be false. because when they equal to each other, it is still not less than. So that means, in this case, I can simplify the logic a little bit because I don't have to distinguish the case of equal versus the case of greater than. Is that making any sense so far? Okay. And now we can close all the end ifs. So I forgot to make this indenting one more level. And we have end if here, and then we have another end if here. This one has one fewer indentation. And then the whole thing needs to be indented. And then we have to return the result, right? And define sub. That's my subroutine. It's a long subroutine, but it doesn't take long to execute because for the most part you can just take the branches, go in, and then make the determine the result. Are we doing okay so far with this? Yep. Go ahead.
Well, in this example, what's the advantage of using a record? If records didn't exist, what would we have to do to get this same thing? How would it be more complex?
That is a very good question. The question was, what if we don't have records? What are records buying us basically? Why do we need this feature? Well, first of all, if you do not have the concept of records, then how many little pieces of information do you need to pass as parameter into this subroutine? You will have 6, right? Because you have the year, the month, and the day of the first date, and then you have the same for the second date. So you will have 6 individual integer type parameters to pass to the subroutine. Now, when you have 6 of those things, it is not uncommon for people to kind of mix and match because they all have the same type. So you can mix and match, you can swap between the day of month and the month without knowing it. You can swap the year of the first date and the year of the second date without knowing it. So there are many, many ways you can make mistakes when you do not have records to package 3 related items into a single item. So that was a very good question, an excellent question, and it also helped me to kind of re-explain why we have records to begin with. It's for packaging things so that we can treat them as one single item when we want to, but we can still break them up into individual items for comparison, like in this case. Yep.
So since you define 0 to date as integers, you can also not only make comparisons, but you can add, subtract, do graphic code too.
Yes, absolutely. So every time you refer to first.m or first.y or first.d, it is really just an integer. You can compare, you can multiply, you can do anything you can otherwise do with integers. Yep.
If you just looked at this, you can't quite tell what it's doing. So is there like a question you can put to answer the result, the answer you get at the end?
You mean like a concrete example to go through this as a trace?
I mean, like you try to determine which number is greater. Shouldn't you put that as like the question?
Yep, well, we have questions. Line 10 is asking a question. It's asking the question of, is member y of first less than member y of second? That's a question. So depending on that answer, I can either go to line 11 or I have to go to line 12 to evaluate the other question. It behaves the same way as any other conditional statements that we have talked about so far. It's just that the components for comparing, they're not individual variables, they are components of records in this case. Are we, no?
I mean, if you didn't see all that code, you just saw the result, how would you know what the result means if you don't have the question like at the beginning? Something that says that you're comparing 2 numbers. This number is greater than this one. I mean, the result would be if the first number was greater than the second one, it'd be true.
Okay.
But you wouldn't know which number first or second?
Well, the first and second are really just the names of the variables. I mean the parameters in this case. So this way it is easy to tell okay, which one is before which other one. The first is before the second.
I know what he's asking. They're the year, month, and day, so your types don't have any value.
Correct, because
that's what he's talking about.
Oh,
that's what
okay.
he's talking about. There's no values in it.
Well, they don't have any
Oh.
values because they are passed by the
You didn't-
invoking
you didn't
statement.
assign any values. That's
We
what
haven't
he's
really got to the
That's what he's saying.
invocation yet.
Yeah.
Right.
The program
Okay.
is not anything.
Okay, I understand your question now. Well, because this subroutine cannot work on its own because we are not giving it anything to process, and that's why these are all parameters so that we can use it to process any two dates that we pass to it. So if you want to make this work, we can define a stub subroutine. Okay, define stub, and then here we have two dates. Okay, so we have we'll have local variable. We'll have today as a date, and then we have yesterday also as a date. So I'm using today and yesterday as names of our variables in this case. And the initialization is going to be quite boring because today.y is 2012, today.m is April, today.d is the 12, and then we can do the same thing about yesterday, right? Yesterday.y is 2012, yesterday.m is also April, yesterday.d would be the 11th. So now that we have two local variables, now we can actually go ahead and try to determine which one is before which one. So now we can say, print, invoke, I use parentheses usually, invoke is before, and now I can choose, which one I will send as first and which one I can send as second. I'm going to flip the order, so I will send today as first, and then I will send yesterday as second. And define sub, invoke stub. So now this becomes a complete program that we can actually trace. Obviously, this is a lot of busy work because the program doesn't really do a whole lot of useful stuff, but it's really just an illustration of the concepts. All right, we'll go ahead and trace it. Sorry? Was it? Okay. So we definitely need comments because we have comparisons in this case. We have line number, but the precondition has nothing to say because we still do not have global variables. I'm using the stub subroutine to basically remove any necessity to have local variables. And line 40 is our only line of code outside of the definition of subroutines. We have return line number to post. And when we get into stub, we also have to define the two local variables. Now, we have two local variables. One is called today, and the other one is called yesterday. But both of these are dates, which means each one will have its own member Y, member M, and also member D, and they all take up one column each. So today has its own Y, M, D. Yesterday has its own Y, M, D. Oops. Go. And because these are local variables, they all start with unknown values. So every single one of these have to start with a question mark because I do not know, what kind of value they will contain initially before I get to my assignment statements. And to make this more obvious, I'm going to combine these three cells into one, just so that we know that today is not just column D, it is actually column D, E, and F. The component Y of today is just column D. The component M of today is just column E, and so on. They can be a little bit smaller like that. All right, so now that we have initialized or allocated the columns, we can get into the subroutine and do all the boring stuff because line 32, all of these are really just giving specific values to the members of the two dates. So line 33, 34, okay, I'm I'm just going to do it this way. Like that. Are we doing okay so far with this code? I mean, this is the really boring part. And then here comes line 38. Line 38 is kind of boring, but kind of not so boring, because we now have a combination of concepts. We have talked about the concept of passing by value already. We talked about the concept of records. Now we're combining those two concepts together. The question now is, how do we do this? If you look at line 38, what are we going to do on line 38? It's a subroutine call, so that means we have to know where to go back to. Are we going back to line 38 itself, or are we going back to line 39?
38.
We go back to line 38 because we have to print the value or the result of the subroutine call. So that means we have to use return info, okay? And it's going back to line 38, and this is really simple because it just has to print out the result of the return value of the invocation. So that's pretty easy. What do I pass to the subroutine here? I'm invoking isBefore, and when you look at isBefore, it has two parameters as well as a result. The two parameters are first and second. So that means when I set up the columns, I will have to set up first and also second. Each one takes up 3 columns. Because we are passing by value. Remember what passing by value is about. It's making a copy so that the subroutine works with a copy of what the invocation or the invoke statement is providing. So that means first and second, each one has y, m, d, and we are making an exact copy of the other one. So that means in first, which is actually our today, it has 2012, 4, and 12 as the YMD. And then second, being our yesterday, has 2012, 4, and 11 for the YMD. Are we doing okay so far with this? Oops. This is how we set up the columns, and then plus result being its own column, because result has to store the actual result. The result is not a pass by value parameter, it is a local variable. So what should I put here? There's a question mark because we don't know what it is. Are we doing okay? Or do we have any questions at this point? This would be a good time to stop and answer a few questions. No questions? This is all good? All right. So once we have these columns set up, we can now continue execution in the subroutine called isBefore. isBefore, for the most part, is really quite boring because we just have to look at each of these fields, go through all the comparisons, and then indicate the result of the comparisons. So what we'll do is we'll take that one out so that we can just look at the comparison. We'll start at line 10. Line 10 is evaluating. Okay, let me put line 10 here first. And then we'll say line 10 evaluates. I'm going to use F to represent first and S for second. Otherwise, it will be too long in the comments column. What is the result of this? Is that true or not? It's false because they are the same. So where do we go next? We go to line 12. Very good. So line 12 is saying f dot y is greater than s dot y. Is it true or false?
False.
That's false because they are the same. So now where do we go?
15.
We go to line 15. Line 15 is going to compare f dot m against s dot m. Is it less than?
False.
It's false. Yeah. You can see how boring it gets at this point.
17.
And then we go to line 17. It is false as well because they are also the same. Then where do we go?
20.
We go to line 20. Line 20 is also a comparison. F dot D is less than s.d is it's false because it's greater than. Then where do we go? We go to line 23. Line 23 says the result is false, so we go here and then turn this to false. And then where do we go? Okay, we get to the first end if on line 24. Okay, and that is the last thing we have to do before this end if. That's also the last thing that we have to do before this end if. And we get all the way out to line 27. So on line 27, we are returning result, which means we locate the return info column, copy and paste the cell, indicated that we are on line 27 right now, and then change the question mark to the value that we are returning. What are we returning? False. False. Very good. So now we are done with line 27. We get to line 28. Line 28 has only one job to do, which is to clean up. Well, two things to do. One is to say that we continue execution on line 38, and then the other one is to clean up all these columns. So we'll go here and then go format cells and change to strike through. And now we are on line 38. On line 38, now the statement looks like this, printf. There's nothing else to do. I can just go ahead and print false to the screen. And then after that, I have, oops, forgot to change the columns here. After that, we go to line 39. Line 39 is the end of the stub subroutine. So that means we look up the return line number column. We tell ourselves we have to go back to post. And now we have no use of these columns anymore. So now they get deallocated. So, and then when we continue execution at post, that means we're at the end of this trace. Are we doing okay so far with this? But don't you think we're wasting some system resources here? We're making too many cookies. Which part do you think is kind of redundant that we did not have to do it this way? We were wasting cookies.
You never waste too much food. You never waste too much food.
Well, the waste of the cookie, or waste of cookie dough, is right here. First and second, as parameters, have exactly the same values as today and yesterday as local variables. And there's really no need to make a copy, because when you look at the subroutine is before, are we changing first and second? We're not changing anything. So that means there was really no need to make a copy, because the whole point about copying something first is so that you don't have a chance to modify the original item. But since we are not modifying the original item, making a copy of today and yesterday is really just wasting resources, wasting cookie dough in this case. So let's go ahead and see how we can make this program a little bit more efficient. Okay, so we will save the program first, and then we'll change it a little bit so that we don't waste cookie dough like in this one. So we'll say waste cookie dough. But now we'll change the program so it doesn't waste cookie dough. How do you think we can change this program so that it does not waste cookie dough? By ref. Very good. Exactly. Because we only have to tell is before where to find the first date and the second date, since we're not changing them anyway. So this way we don't have to waste 6 columns just to make a copy and then do nothing with the copy. In terms of syntax, the change to this program is really not a whole lot, because we just have to change this one to by ref. Also change this one to by ref. And that's all we have to do, in terms of the syntax at this point. But we also have to change the arrows. Now this part you don't have to do with a real programming language, because they don't really use arrows or even use the name of parameters. But in this class we do, because I just wanted to make it very clear that we are passing by reference in this case and not passing by value anymore. Are we doing okay so far with the syntactical change to the program, so that we can now use pass by reference instead of passing by value? So now we go back to the trace. I pretty much have to take out almost everything. Everything from here we have to take out. Okay, everything from here up to line 38 is okay, but after line 38 we have to remove everything, and we want to. Okay, the merged cells are gone as well, so that's good. All right. So what we'll do is we will continue to use a part of the trace. In other words, everything up to line 38 is still good because our changes do not take effect until line 38. Are we doing okay so far with that part? Because I don't want to trace from the beginning of the program because that part is the same, for both versions. And I also have to make sure that I save this name as something else. And this one is more efficient. All right. Now we are back to line 38. Line 38 still has about the same thing because we still have to go back to line 38 after the invocation. We still need a return info here. And in the return info, we have exactly the same thing as last time. Whatever the subroutine returns is whatever I'm going to print. So that part has not changed. However, the other parts have changed. It has two parameters, the first parameter as well as the second parameter. But in this case, the first parameter, oops, what happens? This time, for the first parameter only takes up one column because it is now passed by reference. So we have to say that first, as a parameter, is also known as columns. Let's see, I think that's columns D to F. And then second is also known as columns G through I. Yep.
Can't you also say AKA column today? Or just today?
No, because I don't want to use today, because you can have multiple columns, with the name today, but you can only have one column D, one column E, and one column F. So that's why I use the column, I use the column names because they are unique. But if I use today, I might have some other variables also named today, then it would not be specific enough to say, okay, but which today are we talking about?
All right.
You will see that later on in assembly language programming, there are reasons why I only use the column names instead of the name of the variable. Okay. And then we still have result as a local variable, and result as a local variable has a unknown value to begin with. Are we doing okay so far with this picture? Now that we have set up all the columns, we can continue execution in the subroutine. In the subroutine, we start with line 10. So the rest of this, is about the same as last time, but the mechanism where we get the value to compare to is different from last time. Line 10 is saying, is f dot y, first dot year, is it less than second dot year? The answer is false. Okay, it is not less than. But how we get to that conclusion is now different, because first it's still referring to column D, but column D is saying, don't ask me. Okay, I'm just a reference to somewhere else. So that means if I want to find out what is f dot y, I will have to follow this reference and then go back to column D to column F. And then I say, okay, who has the member called Y? And then D has the member Y, and that way I'm extracting the value 2012. Same way with second dot Y. Second dot Y is looking at column L because that's our parameter second. But the parameter says, I'm passed by reference, so don't ask me for the actual value, but I can tell you who has it. So second tells me to refer to column G to column H. I go to column G and then column H, and then I say, okay, of these three columns, who has the member Y? Okay, column G has member Y, and it has a value of 2012. So that's how I got 2012 to compare to 2012. 2012 is less than 2012 is obviously false, and therefore we go to line 12. So the rest of this program is actually the same in terms of the logic, but in terms of how we get the values to compare, that's different from the time before. Are we doing okay so far with this part? Yes? Kind of? Okay. So I can just replicate the rest here, because it's really the same as last time. F dot m is less than S dot m is false. Then we go to line 17. F dot m is greater than S dot m. It's false. Then we go to line 20. F dot d is less than S dot d. It's false. Then we go to line 23. We get to the conclusion. False. Result gets a value of false. We go all the way out to the return statement on line 27. And then we change the question mark to false. And then we get to line 28, so that we remember to go back to line 38 first, and then we deallocate the 4 columns. So in this case, the number of columns that we have to deallocate is only 4, whereas before there are 7 columns to deallocate, 8 columns altogether.
Should I be on line 28? Not 38.
Sorry?
Should I be on line 28, not 38?
That should be on line 28. Oh, you're right. Go. When we get back to line 39, we are ready to print the result. So we say print false, and then we get to line 39. Line 39 is the end of that subroutine. So now we can go back to this part and then say that these columns are no longer in use. And that tells me to continue execution at post, but there really is nothing else to do at post. So are we doing okay so far? Mixing the concepts together. Because we talked about passing by value, we talked about passing by reference, but we were only using, simple variables, integers and so on. So now that we have talked about records, we're mixing those concepts together and say, but can we use pass by value, the mechanism on records? Can we use pass by value, pass by reference, the concept on records? And the answer is yes. There's nothing wrong with mixing and matching those concepts. Do we have any questions at this point? No questions? Okay. Let me make sure that I save this file first. And we can close only this part. Now in the notes, I used something else as an example. I used the concept of a complex number, but it really is just the same concept, just explained a little bit differently using a more math type of explanation. And I think we covered this part already. And then we have students. Okay, this is the classic binary search algorithm, and we are now applying that to an array of students. So now we are starting to talk about an array of records. You can have an array of integers. Now you can have an array of records. So you should read this part here because the search algorithm has not changed. So let me just kind of point to the binary search algorithm itself. It's this part here. Does that look somewhat familiar? It's your basic binary search algorithm, but there are only certain places where I have made some changes. The changes are all occurring whenever we refer to students. Before we compare an element in the array directly with V, because V is the name in this case. But I can't really do that anymore, because when I refer to students bracket m, what am I referring to? Let's take a look at the entire program. The parameter students is what? It's an array of students, right? So that means each element of students is of the type student. Very good. Now, can I compare a quote-unquote student type with a string directly. Why can't I do that? Well, when we look up a student, it has different components. It has first name, last name, and GPA. If you say, I'm comparing a student record with a particular string, what are you using to compare to that particular string? Well, are you using first name, or are you using, last name? That's why we cannot compare a record directly with a string, because the types do not match. We cannot compare a student with a student either, because what am I comparing? Am I using GPA to compare the two student records, or am I using the first name to compare the two student records, or am I using the last name to compare the two student records? It's not clear. So that means comparison only applies to types that we already know, particularly numbers and strings. Typically, you should not think about comparing booleans, because how do you order booleans? Is true greater than false, or otherwise, or the other way around? Does it make sense to compare true and false in terms of which one is larger? It does not make sense.
If you do it as 1, 0, it sort of makes sense.
Well, if you do it as 1 and zeros, then which one is 1 and which one is 0?
1 is true, 0 is false.
That depends on your transistors, doesn't it?
Electronically speaking, 1 is true and 0 is false.
Well, electronically speaking, they don't care about the semantic of whether it is true or false, because electronically speaking, you can use either an oscilloscope or you can use a multimeter to measure the voltage of a pin. Okay, this pin has a voltage of 3.3 volts. The next pin has a voltage of 0. But what makes you think that 3.3 volts should be interpreted as true versus 3.3 volts interpreted as false? That selection is somewhat arbitrary. Okay. Now, even in electronics, since you guys mentioned electronics, even in electronics, there are certain pins that they have called inverted meanings. In other words, when the signal is high, when the voltage is high, it means the negation of what that pin is meaning. That it's also called an active high signal in that case. So that means the assignment of the meaning true false to a signal that is high or low is actually somewhat arbitrary. I mean, you can't really just say that we have to do it this way. Well, we can easily flip it around and do it the opposite way. Okay. Now, having said all this stuff here, when you get into the C class, you'll be awfully confused. So I have to warn you ahead of time, because in this class it is all theoretical. So we say that Booleans you cannot compare Booleans. The only thing you can compare with Booleans is whether they are the same or not. Okay? Does it make sense to say that true is the same as true? False is the same as false? True is different from false? That's okay. You can say they are different, but you cannot say one is greater than the other one or not. But when you get to cisp300, your professor will tell you, guess what? C does not have Booleans. There's not a shred of Boolean in the C programming language. What would be your first reaction? Well, then you have the next question you're going to have is, then how do we represent true and how do we represent false, right? Because without the Boolean type of true and false, how are we actually going to? Okay, let me give you one example. Let me use mousepad and give you this example. Okay, so I'll just say that in C there is no Boolean type. All right. If there's no Boolean type, and it still allows you to compare integers like 45, less than or equal to 67, you can still write expressions like this. The question is, without a Boolean, what is the actual result of this comparison? It's not true. It's not false. Guess what it is?
67?
Nope.
Yes.
That's all that it is going to give you. Anything that is non-zero in C can be interpreted in the context of true false to be true. That's all C and C++ will tell you. Now, what if you have something else? What if you have I don't know, 6 does not equal to, that's not equal to in C, by the way, is 6 does not equal to 6. That expression is false because 6 equals 6 is true, so 6 does not equal to 6 is false. But since we don't have Booleans, we don't have true and false, what is this going to give you?
0.
That's all it's going to tell you. So anything that is non-zero, meaning 1, -1, 5, 10, -20, and so on and so forth, they are all considered true. Anything that is 0 can be considered false. Now suddenly, it opens up the floodgate. It opens up a big, huge can of worms. Things that I said do not make any sense in this class suddenly, quote unquote, makes sense in C. Because now you can suddenly have something like this. You can say I was trying to think of, oh, there you go. Now you can suddenly have expressions like this. You can say, okay, let's say we have, this is a C syntax here. But I think most of you can say the condition is true. Okay. This is all in C syntax, but I'm pretty sure most of you can just kind of guess what this statement means, right? If the condition, whatever the condition is inside the parentheses is true, it's going to print the string, the condition singular is true. Otherwise, it doesn't print anything. Okay, is that okay so far? Mapping our pseudocode into actual C code. Before, I told you guys that whatever you put here has to be Boolean. It has to be something that gives you either true or false. You can put a comparison there, you can put an or, you can put an and, you can put a not, but you don't put a product there, okay? A product of 2 integers. But now you can. You can say, if I times j, it's in C, this is perfectly fine. Because the way C looks at Boolean is just 0 versus non-zero. So if the product of I and j turns out to be 0, it will be interpreted as false and nothing will be printed. If I times j turns out to be non-zero, it can be anything. Okay? If it's non-zero, it can be 23, it can be 2016, it can be -100. It doesn't matter what it is. As long as I times j is non-zero, it's going to be considered as true because of the context of a condition in a conditional statement, and the statement will be printed. Okay? What do you think? Do you think this is a good thing, or do you think it's a bad thing? Because things that I said in this class should not happen, makes no sense, it suddenly becomes possible in C. Is that a good or bad thing? It's a very, very, very bad thing. Because what this means is C is leaving a rope long enough to shoot yourself in the foot.
Yeah.
And I think that's actually a book with a subtitle like that, that talks about all the pitfalls, all the common problems that people have when they program in C. Now, in C, the conjunction operator is ampersand, ampersand. What if you forget it is double ampersand, and use a single ampersand? Guess what? It is also an operator, except it is not conjunction. So your program will still, the compiler won't complain. The compiler will just say that, yeah, the syntax is fine, except it doesn't do what you think the program should be doing. So when you get into C programming, you will see all kinds of problems that you will encounter that you don't really encounter in pseudocode.
What does a single ampersand do?
A single ampersand is called a bitwise AND operator. It's different from a logical AND operator. And the same thing with double bar is logical OR, single bar is bitwise OR.
What It's
Yeah.
bar and percent bar.
Hmm?
So like the endless
There's no such thing like that.
combination of things?
Now,
Okay, just making
now
sure.
since we're talking about leaving a rope long enough to shoot yourself in the foot, this seems to be fine, right? I'm comparing I and J. If I is in fact the same as J, it prints the message the condition is true. Otherwise, it prints nothing. It seems to make sense. The double equal symbol in C means comparison, equality check. Are we doing okay so far with that? But C also let you do something like that. The meaning of a single equal is assignment. It's the same as our left arrow symbol in this class. Now, what is the big deal of double equal versus single equal? When you have a double equal, are we changing the value of either side? No, we are just checking whether they are the same or not. When you use a single equal, are we changing the value of one side or the other?
Yes.
We are changing one side, right? We're changing I in this case. So, but why would this make any sense? It's an assignment operation. So what are we going to use to say it is true or not when you have an assignment operation? Well, C has this real nasty habit. The assignment operation is not a statement, it's an operator. In other words, you can embed it in other statements, in other expressions. It returns the value of J in this case. I equals J is going to the whole thing. It has the value of J. So in this case, if J has a value of 0, then I will get a value of 0, and this condition will be considered false. So now you have two things going on because it has two incorrect results. Because one, it is changing the value of I, which you probably did not intend. And at the same time, it is also not really comparing. It is using the value of J as a Boolean by itself to determine whether to go into this statement or not. If J has a non-zero value in this case, then I will get the same value as J, but the expression itself will be considered true because it is non-zero. Then it will print this message out, which is way different from what you think it is supposed to be doing. Okay, so this is why there's a book. Let me see if I can find it on Google. C programming language, leave rope long enough to shoot foot. Enough rope to, okay, I was wrong. Okay, fine. Enough rope to shoot yourself in the foot. Rules for C programming. C and C++ programming. So it really is a book. The rating is not that good, but the fact that somebody spent time to write a book like this should give you plenty of warning ahead of time before you take cisp360 and say, I better pay attention to those little details, because if you don't, you might be doing something, your program might be doing something that is way different from what you think it should be doing. Sorry?
I'm just doing the math of how much one is.
Say again?
Nothing.
Go ahead.
Why would you want to assign? As I understand, I've done this error and it was like really annoying because like I was doing my assignments in a different program and I wasn't thinking to look for that. I probably took like a half a day tearing my hair out.
Mm-hmm.
But I've never seen any code or anyone actually use that syntax to assign it. So why is it there? And why isn't there like a warning in the compiler like?
That is a very good question. The question is, why is there enough rope to shoot yourself in the foot to begin with? Why would someone design a programming language that leaves enough rope to shoot yourself in the foot? Well, the answer is really quite simple. The C programming language was invented by Carnegie and Ritchie. One of those two guys died, shortly after Steve Jobs passed away. Of course, nobody noticed, because Steve Jobs was way more famous and way more attractive, than the old guy with beard and stuff. So anyway, but he was a guru in terms of programming, and he and the other guy, they were writing the Unix operating system at the time in assembly language. Now, most of you still remember my analogy of assembly language programming. It's building something from grains of sand, the smallest possible component in programming. will be the individual instructions that your computer, that your processor can execute. Assembly language programming is basically building programs from the absolute smallest block of construction. So these two guys were kind of getting fed up because even though they're good programmers, they don't like the tedium of having to specify instructions by instructions by instructions. So they invented the predecessor of the C programming language called BCPL. Now people call it before C programming language. But BCPL was basically just a shorthand for things that they want to do, so that they don't have to write everything in details and details and details. So with those guys, having the assignment operation as an expression and be able to use it inside something else was actually handy because they were seasoned, experienced programmers at the time already. The C programming language was always invented by hackers, as in experienced programmers, for hackers, for themselves. It was never intended as an instructional programming language for students to get into programming. Okay, they had Pascal, the programming language called Pascal, for that particular purpose. Now, the reason why you have to learn C and not Pascal in cisp300 is because in industry, nobody uses Pascal. They all use C or some sort of derivative of C. So the colleges and universities decided, why do we want to teach students something that they have no use of after they graduate? We might as well just use a programming language that industry uses so they will be ready for industry when they get out of universities. That's why we are using C and C++, and that's also why it has enough rope to shoot yourself in the foot, because it was never intended as a programming language for novices. You can look at this as a power tool that was not intended for apprentices. There's no safety feature. The circular saw has no safety feature whatsoever. There's no safeguard or whatnot because real carpenters know what not to do. I mean, that really is the whole reason. I mean, I'm not exaggerating. I mean, when you get into the C programming class, you will see and experience for yourself what I just said. Because everybody has to make that kind of mistake at least a couple of times before they learn, okay, I better not do this anymore. All right, I'll see you guys next Tuesday. Have a nice weekend. And remember, next Tuesday is exam 2, so don't miss it. All right. Can we turn off the recorder first?
Yeah.
No need to record this part.